to know the planet, to know the universe, to find out what makes things work and why things are the way they are through observation, study, and experimentation. We can unleash the power of the universe and make almost anything happen. This is Understanding Science.
Science. It helps us understand the world we live in, explain why things are the way they are and happen the way they do. Hi, I'm Dr. Science. Scientists use general principles to unveil the secrets of the universe, principles that you can use to investigate and discover the world around you. Scientific problem solving is the key to unlocking the mysteries of science. The world we live in is a complex spaceship. There are so many different types of phenomena that must be explained that scientists have to become specialists. Science specialists study one specific area of science, like biology, physics, chemistry, astronomy, and geology. And the more we know about our complex world, the more specialized these sciences become. Biology, for example, can be divided into many other subdivisions like zoology, the study of animals, botany, the study of plants, microbiology, the study of microscopic organisms, or cytology, the study of cells. And even though there are many specialties in science, all scientists approach their problems in the same basic manner. This universal approach is the scientific method. The steps of the scientific method are basically the same in all areas of science. The first step in the scientific problem solving is to define or state the problem. Say we'd like to find out whether different salt solutions boil at different rates. Step one is to clearly define the problem. Do different solutions of salt and water boil at different temperatures? Next, as a scientist, you would research the problem or gather information about the problem. In this case, you'd want to know the chemical properties of salt, or sodium chloride, in water. Salt, as we know it, is sodium chloride. The symbol for sodium is Na. The symbol for chloride is Cl. Together, these elements form the compound sodium chloride. H2O is the symbol for water. Hydrogen and oxygen combined. After researching the problem, you are now educated on that particular topic and are ready for step 3. Form a hypothesis. A hypothesis is an educated guess. Will water boil at a higher temperature with or without salt? Because we have researched the makeup of salt and water, our hypothesis:
the more salt in the water, the higher the boiling point of the water, or the slower the water will boil.
Our research also shows us that once liquids reach their boiling point, their temperature does not rise any further. The next step, step 4, is to test the hypothesis. And this is what scientists call an experiment. The experiment is designed to test our specific hypothesis, that the more salt in the water, the slower it will boil. Now, before they can begin the experiment, scientists must gather the materials needed. My assistants today are Brian and Nina. For this experiment, we will need water, sodium chloride, 4 beakers, a graduated cylinder, a triple beam balance, a glass dish, a Bunsen burner or a hot plate, a thermometer, a pot holder, a ring stand, and a wire screen. Now, when working in a laboratory, it's very important to be safety conscious. The lab can be a dangerous place, but if you know how to work safely, it can be an exciting adventure. Today we'll be working with glassware. Now, always use clean glassware and thoroughly dry any glassware that you'll be heating in an experiment. You should also use heat-resistant gloves when heating glassware. And anytime you're working in the lab with chemicals, projectiles, heat, always wear safety goggles. Never heat anything, particularly chemicals, unless you're instructed to do so. Never heat anything in a closed container, and don't reach across a flame. When using fire, be sure to work with clamps, tongs, and heat-resistant gloves. When heating substances in a test tube, turn the opening away from you and others. And when you're working with chemicals, never smell any chemical directly from the container. Don't mix chemicals unless you're instructed to do so, and never touch or taste any chemical. Use common sense, like when you put acid into water, pour the acid into the water so only the water will splash. Now, when you're using the chemicals, be sure to rinse off your skin and clothing. Also, keep the lab clean and put equipment away when you're done, so we'll be ready for the next experiment. We've already gathered the materials we need for this experiment. Now we can plan the steps we're going to take, or our procedure. First, label the beakers A, B, C, and D. It's important that the beakers are the same size, shape, and have the same amount of water in them. Measure 50 milliliters of water into the graduated cylinder. When measuring liquid, be sure that the meniscus, or curved bottom of the water in the cylinder, is at the same line for each measurement. Now put 50 milliliters of water into each beaker. Light the Bunsen burner and place it under the ring. Take beaker A, which will contain only the water, and place it over the heat. While beaker A is heating up, begin measuring the different amounts of salt to add to the other three beakers. The salt is the variable, or factor being tested. We will purposely be changing the amount of salt in each beaker, and this is known as the independent variable of the experiment. We're looking for a response, or a dependent variable. This is what happens to the boiling point of the beaker with different amounts of salt. In an experiment, only one variable can be tested at a time. This helps to ensure that the results are caused by one and only one factor. In our experiment, the factor being tested is the salt. To measure the salt, place the glass dish on the triple beam balance and adjust the balance to 0. Measure out 0.1 grams of salt, or sodium chloride, into the dish. Put that salt into beaker B. For the next variable, measure 0.2 grams of salt and add that to beaker C. Then measure 0.3 grams of salt and add that to beaker D, which now contains the highest concentration of sodium chloride. Because there is no variable in beaker A, it is called the control of the experiment. The control is set up exactly like the beakers with the variable, except that it does not contain the variable salt. I'm also using the same thermometer throughout this experiment because not all thermometers are calibrated exactly the same. If we were to use different thermometers for each beaker, we'd have errors in the results of our experiment. The metric system is used by scientists all over the world and is known as SI, the International Scientific Unit of Measurement. We know that water boils at 100 degrees Celsius. Read the temperature of beaker A. It should say 100 degrees Celsius. If the boiling temperature isn't close to 100 degrees Celsius in beaker A, the thermometer you're using might be calibrated incorrectly. After removing beaker A from the heat, place beaker B over the Bunsen burner. When it begins to boil, place the thermometer in it, and after a few seconds, read the temperature. Repeat the process for beaker C and D. Step 5 of the scientific method begins during the procedure, recording the data. Data is what we call recorded observations and measurements. In this experiment, the data includes the temperatures reached by each beaker. When you're doing the experiment, check each of the variables when they boil and record these temperatures. We can set up a table to help organize the data and make our observations easier to understand and compare. Data must now be analyzed to lead us to our conclusion.
From the data table, we can see that our control beaker A had the lowest boiling point. The variables, beakers B, C, and D, boiled at higher temperatures, and beaker D, with the highest concentration of salt, boiled at the highest temperature.
From this analysis, we're ready for the 6th step of the scientific method, state a conclusion. The analysis leads us to the conclusion.
When salt is dissolved in water, the boiling point is raised. Therefore, water without salt dissolved in it boils at a lower temperature than salted water.
After you've come to the conclusion from an experiment, it's interesting to go back and see if your hypothesis was correct. Our original hypothesis,
The more salt in a solution of water, the higher the boiling point of the water,
was the same as our conclusion statement. Scientists often retest their experiments to see if they came up with the same analysis. Each time they test and retest an experiment, it's called a trial. The more trials you have in an experiment, the more accurate the information you've collected is. After completing an experiment, scientists often have new questions to be answered. For example,
we now know that salt raises the boiling point of water, but does it also raise the freezing point?
scientists have always found that once one question is answered, there are many more left unanswered. And it is their quest to find the answer to the next question. Have you ever wondered why cooks put salt into water that they're going to boil, or why salt is put on icy roads? Sometimes in nature, it is very difficult to come up with the scientific conclusions in the complex world we live in. So, after studying facts, making observations, and analyzing the results of experiments, scientists may develop and propose a theory. A theory is the most logical explanation for events that occur in nature. Once scientists propose a theory, it must be tested over and over again. If a theory is tested many times and the results are always the same, the scientists may call it a law. Many of the things we believe to be true or laws are actually theory, like the theory of relativity and global warming. Now you know how to solve a problem scientifically. Number one, state the problem. Make a clear statement of what it is you want to find out and put it in the form of a question. Number two, research the problem. Gather information that will educate you about the problem. Number three, form a hypothesis. That's when you make an educated guess about the answer to your question. And number four, test the hypothesis by performing an experiment. Remember to test only one variable and always have a control to compare the variable to. Number five, record the data collected, or record your observations. It's always easiest to present your data in tables, charts, or graphs. Then analyze the information collected in the experiment. Number six, state a conclusion. Compare your conclusion to your hypothesis and see if it is correct. You might think, oh, I'm not going to be a scientist, so why should I be able to solve problems scientifically? Well, now, there are many careers that are science-related that don't seem like science at all. You might want to be a computer artist. Computer programs can make images of things that have never been seen. Data is collected and converted into visual images. Most animated films and many films' special effects are created through computer-generated graphics. Another career that doesn't seem to be related, but is photography. Photographers use principles of light and color to capture beauty in nature. Even firefighters have to know scientific principles, since all fires are not alike. Each substance burning has different characteristics, and firefighters must be familiar with the chemical properties of what's burning and put the fires out. Through the scientific problem-solving method, scientists have answered many questions about our world and discovered that there are many more questions yet to be answered. They've even solved some of the mysteries of the universe. To have the ability to solve a problem scientifically is to know no boundaries. I'm Dr. Science. I'll be back.
This program has been a presentation and production of TMW Sales Company. For information on other programs offered by the company, contact the phone numbers on the screen.